Good morning, ladies and gentlemen. My name is Robin, and I heartily welcome you to our second installment of H2UB Insights. I'm glad you tuned in for our today's session. Um, I have to inform you that for today we have a special and slightly different approach for this session, as I want to inform you about unforeseen circumstances that have arisen, requiring us to make a slight adjustment for our session's agenda today. Our dear friend and startup founder David from Israel, who was scheduled to present today his innovative approach to you, has been called away due to the current situation in the country. As many of you are aware of the situations can demand immediate attention and commitment. And we fully understand and respect their need to prioritize their responsibilities. So David will not be with us for today, but as we know, he's safe and sound, and we hope all the best for him. We extend our thoughts and support to our friend during this challenging time. Safety and well-being are of utmost importance to us all, and we stand with them, as they navigate those hard circumstances. So we are sorry, David won't be with us for today at least. But we want to appreciate that you, the audience, joined us for today's session. And so let us embark on an enlightening journey to the realm of safety and sensing technologies, exploring their pivotal role in safeguarding against hydrogen gas and flame related hazards. We are honored to be joined by our partner, MSA Safety, an industry leader with a rich history in providing safety solutions, as well as an innovative access to how they work with startup and disrupt the status quo in critical fields. And our objectives for today are to emphasize on the safety significance. We will underscore the paramount of importance of safety in the industry involving H2 gas and flames, because safety is just not as safety is not just as a priority; it is non-negotiable when working with like dangerous flames and gases. And then we will see how groundbreaking the approach of our partners are, and see how also we can foster collaboration with startups and corporates in a different way today. Throughout our session, we encourage you, the audience, to actively engage with me and our guest for today. Ask questions and share your insights. And together we will create a platform for knowledge exchange, collaborative opportunities, and most importantly, heightened awareness of the urgent need for enhanced safety measures in the industry dealing with hydrogen, gas, and flames. And now I will welcome our guest for today. It's Claudio from MSA. Good morning. Glad to have you.
Good morning. Hello, everyone.
I think after I had my introduction for H2UB and myself, I would like you to have a short introduction of yourself to see with
Okay.
whom we are dealing with today.
All right. So, hello, everyone. So, first, before to introduce myself, I would like to even join your talks regarding to David, our friend David in Israel. I hope that he is safe and his family as well. Short introduction of myself. So my name is Claudio Feccarotta, located in Italy, working for MSA now more than 23 years in the fixed gas and flame detection business unit. I cover a different role in the company as a project manager through then experiencing the sales and then become the business development manager now covering international market for hydrogen development. What we are going to present today is something very sensible. We are talking about safety. So Robin already introduces something on this topic in a high level, and I would like to go in deep how MSA is contributing in empowering through our sensing technologies and support the hydrogen market, the hydrogen business to become safer, even considering that these kind of technologies are not new in on the market, but is quite now more decades that are available and are suitable for the hydrogen application as well. Let me go through the three main topics I would like to cover today. It will be hydrogen challenges, layered protection, summary, and conclusion. Starting with the hydrogen challenges, of course, we know that hydrogen is a flammable gases, is bringing some risk and also challenges, which we are well known about the potential risk and challenges we are facing every day. We can start from the left to see that the propensity to leak. What that means? Hydrogen is the lightest molecular in the universe. We know that. Is a flammable gas. Is quite easy to leak from small holes, and that is mainly based on our experience. The major concern from the people at work or people managing this gas regarding the behavior of this molecular to become a cloud then in the environment, to become more complex to manage and avoiding that with leaks. However, let me say that leaks is part of the nature of the life of this molecular, and the only way is to mitigate the possible risk about the leakage. Of course, preventing the leakage is the first thing to manage every day. Propensity to ignite, what that means? We know that is a low ignition energy, a wide flammability range. So it takes a very low energy to ignite the cloud formation, and the flammability range, if I'm not mistaken, is from 4% volume up to 75% volume. For sure, is 4% the lowest flammable limit. That is saying to us that is a very wide range of flammability. So that's why it's also concerning the people at work in regards of the potential explosion of the hydrogen cloud. Fire consequence. We know that pure hydrogen flame is completely transparent. Then there are some video in the net where it's light blue, light yellow. I've seen with my eyes 100% hydrogen is completely transparent, so not visible at all from our eyes, and it requires a sophisticated technology to see that. Human related. This is something where is the most consequence to avoid during the formation of the hydrogen cloud, and then the explosion and the detonation, or even the flame consequence, is a potential injury or loss of life. Let's remember that the formation of hydrogen cloud is also colorless, odorless, and tasteless. So based on our human sense, we cannot even recognize we are in a hydrogen cloud. So that is very complicated, and that's why we have to rely on a sophisticated technology in order to detect at a certain very quick time that there is a leakage in our plant. Moving forward with that, what I wanted to share with you is one of the possible scenario that might happen to a leak source of hydrogen, because in our background we faced also situation where, being the fact hydrogen is very light, it flies away, it is going up, so people doesn't consider this as a factor of risk, but they convert this behavior in a safety behavior, which is wrong, because we have to consider that most of the time the hydrogen plant is under pressure. If you think about hydrogen fueling station, if you think about the storage, if you think about the compressor, so in a different stage of the hydrogen plant, we are facing situation where the gas might be compressed. And when it's compressed, is the behavior of the cloud formation is completely different than in ambient atmosphere. So based on the graphs you see I'm sharing in the presentation, is a case where we can state the leak is unpredictable. It is unpredictable in direction, in behavior, being the fact that there is a different factor can influence the shape of the cloud formation outside of the leak source, like the wind direction, the wind speed, pressure value, and also the location of the detector and which type of technology. Those last two are consequence of undetected leakage, which is fundamental in to mitigate or reduce the risk after the leakage. Let me say leakage, we cannot stop the leakage. We can, or we cannot avoid leaking, but at least we can prevent or mitigate the possible consequence of this. This table is quite simple, is used mainly in also in other cases for risk assessment or even in the 61511. Is in a matter of time in the horizontal line, you see the consequence coming from the left on when the gas is released. So the time you have the leak, the colors are telling you, like the cross light, the sense of urgency might need to detect the leak or the consequence of the leak, like we are going to see the flame. The three lights you see on the right, we put some icons where is referring to our sense. Yes, because of the technologies we have in the detector to detect the hydrogen leak or flame can be aligned or associated to the human sense, like hearing, smelling, and seeing. Back to the table, you see that whenever the gas is released, considering the hydrogen under pressure, immediately it's fundamental to detect the leak. That is green, it means it has to be faster, and the only technology is the leak detection, ultrasonic leak detection. If there is no any injection, you will see there will be a formation of the cloud, and we are in the yellow part. And what that means, the cloud is somewhere. If we have also obstacles, might also aggregate in a specific area of the if you think containers where the electrolyzer is leaking inside, then it might be that can even trigger the explosion then, and you have the red zone where the explosion is consequence of cloud formation or even pressure of the gases leaking. So that is the situation where we have to take in mind. Please remember the colors as well, because it will help you to recognize the technology. Based on the technology, starting from the ultrasonic on the left, the first column is in very quick, reacting very quickly. We are talking about a few seconds, couple of seconds. This technology is able to detect the leak of the hydrogen fundamentally under pressure. So the ultrasonic doesn't work when we are talking the gases is not under pressure. Typically, it can work up to above 5 bars. That is the minimum requirement, where the molecular is there is a friction between the molecular escaping from the hole. Is not affected by the wind because it's hearing, and is fundamental to have an implementation of artificial neural network in the software to avoid any false alarm coming from the background noise. Yes, because the background noise is one of the most affected false alarm, can trigger a generic ultrasonic devices. Going through the other two technologies, when in the orange zone, remember the cloud has formed already and maybe segregated in a specific area of the plant or even of the components. We have a couple of the technology able to detect in a different ranges the cloud formation. The first one is very common, is now many decades used and with a huge install base, is called catalytic. It's based on two cat beads which reacting when the molecular of the hydrogen is in contact. There is a change of the Wheatstone bridge where they are connected to, and then we have the signal out. Range covered is 0 to 100% LEL. The same it works with the electrochemical. The only difference is that we are talking about a cell like a battery, where inside there is an electrolyte is reacting where is in contact with the hydrogen cloud. What are the two differences between catalytic and electrochemical technology? Is just the range. Electrochemical is much more sensible, so it is suitable for specific, mainly indoor application where requires the very sensible detection. We are talking about ppm. To give you a sense of usage, catalytic is mainly used like 90% of the case. Electrochemical is very specific. Talking about the technology to see the flame, remember it's a transparent flame. We are talking about UV IR technology. So we base on the fact that two different technology, as I say, ultraviolet and the infrared, the combination of the two are able to detect the possible false alarm coming from the sun ray or coming from different sources, light sources. And with the infrared is tuned specifically for the emission of the hydrogen flame. When I say specifically on the emission of the hydrogen flame, means that hydrogen flame is emitting a wavelength different than the hydrocarbon one. And you know, hydrocarbon is quite visible, is emitting CO2, is emitting different substances. You see the yellow color of the flame, which is totally different than the hydrogen one. So those are the four main technologies on the ground that able to detect the hydrogen gas leak and flame behavior, which is characteristic for hydrogen. So no infrared, no laser are applicable for this. The complete package of this technology, of course, are built in a specific detector that's complete the package, like we say, the protection layer package, which when are used completely in a matter of safety in the hydrogen plant, this will reduce dramatically the risk of possible escalation regarding the gas leak, hydrogen gas leak. So, of course, as I say, some technology are not applicable at all when there is a specific characteristics of the leakage, like ultrasonic. However, the combination of the three sense of technology help to mitigate dramatically or drastically the situation of possible escalation. Just to give you a sense of the products, we are talking about ultrasonic gas leak detection. As I say, is more on specific technology with an artificial neural network. What that means is a software, very sophisticated algorithm in the software, able to recognize the environmental background noise, false alarm, or even to understand the footprint of the frequency coming from the leakage. In terms of conventional gas detector, we are talking about the Ultima X5000. You see the detector on top on the right. Is a typical transmitter where is smelling the gases using the two technology I've mentioned before, the catalytic and the electrochemical sensing. Well, these kind of products can even have more features to avoid the influence of the external factor. We use also different technologies to improve the reliability of the detectors, the detection. Also, we improve the different techniques like the dual sensor and the remote sensor in order to really embrace all the challenges that we faced based on our experience in the hydrogen production plant or in any kind of hydrogen project we have done already. So based on our experience, we have developed different technologies or techniques in our products to fulfill the requirement of this safety in the hydrogen plant. Finally, the H2UB ultraviolet infrared flame detection, as I mentioned, is very specific. Is the combination of the two technology is very fast response, very wide range in terms of optical view. When I say fast, we are talking about a couple of seconds to recognize the flame, and that is fundamental because the flame is detecting the flame is the last resort in order to reduce the damage after the detonation or even the triggering of the flame of the hydrogen cloud. So, summary and conclusion. We are going to now approaching to the last slide. Well, if you remember the graphics, the shape of the clouds formation, you can even see that the tree technology or the combination of the three technologies are able to detect the different shape of the hydrogen clouds formation. Cannot be affected by the wind direction because of using the ultrasonic technology is fundamental on avoiding the undetected leaks, and the combination of the three technology are securing a very high reliable solution in order to make safe the hydrogen plant. And that is fundamental because in some cases is more complicated, is very specific. We need to analyze the situation, the condition, obstacle. So there are different factors influencing how the firing gas system looks like or will be designed. Also, the logic with the controller is one of the sensible things that we need to consider based on the fact that we are talking about safety, and that is a very critical and crucial talking with hydrogen. Complete hydrogen safety solution. So we need to take in account the three techniques, the layered protection concept that I've explained to you with the three colors, with the three human sensor, just to give you a very quick sense of how they works. As I say, hearing, smelling, and seeing, those are the three ways to detect the leak and the flame. Ultrasonic sensor here, and the conventional gas detector are sniffing, and the flame are seeing the consequence of the flame. Layered strategy reduces the incident of hazard and propagation. As I say, the complete package is a quite high level of reliable system. Not always can be used due different factor. Maybe we can discuss later with Robin to go in deep on these things. Pressure is one of the consequences on this, but we can have also advantages in terms of weather condition cannot be affected by some technology, like can do more effect on others. However, the complete package is this right solution to compete with the risk of the hydrogen leakage. So that was my last slide. Now we can open the panel, and if you have any question, you can even contact us at h2 at msasafety.com. This is our specific hydrogen email address. We open it since now more a couple of years, where you can reach out and our expert or myself can answer to your question. So, Robin, that was my last slide. Here we go.
Thank you so much, Claudio, and thanks for the insights to the products of MSA. Um, as the audience might have some questions, please feel free to ask them in the YouTube chat. The panel is slightly different for today, so it's just both of us. And as I'm not an expert in hydrogen safety, I took some things from your presentation, and I might ask you some things I might not got right, or I have some misunderstandings
Okay,
so far,
go ahead.
if it's fine for you.
Okay.
So thanks for setting up the scene on hydrogen safety, and yeah, I will start with the things I might got not that good. So the first thing is, have you faced any misconceptions or wrong understanding concerning hydrogen behavior, as mentioned so far?
Yeah, I've seen something like the slide at the end or at the beginning with the shape of the clouds, and well, we faced a few times. Let me say, people are understanding or considering hydrogen safer because it goes up due to the fact that the molecular is light, as I say, I mentioned during my presentation. Why we faced this kind of misconceptions, or like you use in this word in your question, because it is for my personal experience is wrong. I mean, in terms of behavior of the hydrogen molecular being light and flying away, well, it can happen, but what happen when is under pressure? We know that any gas under pressure leaking can go in any direction, 360 degrees, up and down, left and right, and is unpredictable, the leak direction. So if you consider this as a misconception, I think that the audience or even the safety people or the owner has to reevaluate the misconcept on hydrogen is light, my plant is safe. This is exactly what I heard during the conversation with some people. As I say, in some cases is correct. However, remember my slide where I wanted to even use that slide in order to be more clear on the fact that in the theory and in the practice as well, this is not happening at all when it's under pressure. Especially, think about hydrogen filling station, we can reach 700 bars. So the pressure can even influence dramatically the shape of the clouds outside of the leak sources.
Okay, thank
I
you.
hope I
So
have answered.
yeah, definitely, because when you commonly think of hydrogen, which is lighter than air, you always think it's going up to the ceiling, and yeah, when the pressure comes in, we definitely have some other picture of it
Some
spreading
people
in
were
the room.
shocked when I showed that slide, and they say, "Oh my God,
Yeah,
Claudio, what are you saying?"
it's yeah, a different approach of yeah, getting to it. I think we have a question from the chat. Um, So Andreas is asking if the same technology can be used for detecting both hydrogen and other gases. For example, investigating the use of ammonia for H2 transporting. Do you have an answer to that, Claudio?
Oh, that is a good question. Even because it's open the view of the application of or the usage of the green hydrogen. We know that ammonia is one of the emerging green market again because it's collateral to the green hydrogen production. Um, yeah, I mean the technology we showed, we presented today, are able to detect even other flammable gases, especially the ultrasonic and the catalytic are able to see other flammable gases. Again, the ultrasonic are very specific for gas under pressure. Is very specific to detect in the quick way the leak, and conventional gas detector catalytic can even see the flammable gas like ammonia in the cloud formation. There are also other type of technologies able to see different flammable gases out of hydrogen. We can mention the infrared, we can mention the laser as well, but we are talking about other type of flammable gases which are very specific, as I say. But this question was good to mention the ammonia as well because it's quite completing the words of the green hydrogen usage in reality outside. And different technology are specific, like a different other technology or the common technology can be used in both cases for hydrogen or even for other flammable gases. It's just a method of calibration for catalytic. Ultrasonic is applicable whenever there is a flammable gas under pressure.
Okay, thank you. So thanks for the answer. I hope that answers Andreas' question. And if not, we can maybe point something out as we need it.
Mhm.
Um, so you told us about the different types of technology which are available to detect yeah, leaks and flame. You presented in yeah, the presentation from MSA and your products. Um, what do you think is maybe most important, or do you think everything is definitely needed to be yeah, super safe when handling gas and flame?
Yeah, that is another good question. I mean, you made this question in a way that like the customer is also approaching to us in the same way. Do we need all? Well, as I say, the complete package of technology is building up the concept of complete protection layer. And the protection layer is fundamentally to have the three techniques, the three technologies in place in order really to avoid the catastrophic consequence of the leakage of hydrogen, especially. Um, the the usage of the ultrasonic is one of the technology where is not always applicable in some cases. And as I say, the gas has to be above 5 bars. That is the main characteristics. However, then the techniques can be, or the technologies, let me say, can be used in a specific or approaching in a specific application, like ultrasonic is more suitable for outdoor application where there is an influence of the wind. You know, the shape of the cloud can be influenced by the direction or the speed. In that case, the catalytic or the electrochemical cannot, or the likelihood to detect the gas formation can be affected by the weather condition. So can be used also the conventional technologies. Yes, can be used, will be fundamental where to locate the installation and the position of those sensors. Catalytic electrochemical can be used in outdoor and indoor. Of course, indoor will be better used because it's not influenced by the weather condition. Talking about flame, that is applicable for both application, outdoor, indoor, and not affected by the weather or even any flame sources or false alarm, because it's quite immune based on the two sensor and the combination in the technology. So I would say that every plant is very specific. Our approach is to discuss with the customer during the design phase, especially is the right approach, because the customer will save more money rather than to change at the end during the commissioning of the plant. We can support with based on our experience which technologies are better and suitable for the application. In the hydrogen market or in the complete supply chain of the hydrogen, green hydrogen, we can have the production where can be the electrolyzer, could be in a shelter, could be in container. In storage, we are talking about a cylinder pack, trails, we can tanks, distribution, pipeline, compressors, and then also where the regular people are using the high pressure hydrogen, like in the hydrogen filling station at the dispenser. So those macro area is where the technology needs to be evaluated properly. MSA, based on our experience, can support the customer to understand how the technology can be used and even which one is the best for.
Okay, thank you. So it's good to know that there are so many different applications and fields of yeah, where to use and choose the right application. So as my German understanding is, the more the merrier when it comes to safety. So I have the understanding that you need everything packed up and then it's fine. And yeah, that it depends
Correct.
definitely on where to use your applications and yeah, the different fields which are needed.
Correct.
Um, do you, depending on safety again and how crucial it is to yeah to maintain safety when you handle H2 gas and flame. Um, we might not know everything, but what are potential consequences when you neglect safety measuring? And yeah, maybe you can give us a bit of awareness of how important the
You are
techniques.
touching you are touching a very sensible point now. It's not a matter of experience or technology, but we are touching the pocket and the heart of the people in this case. Okay, why I'm saying the pocket and the heart of the people. The pocket because in traditionally safety is mainly an expensive system. Is always don't take don't get me wrong, annoying when needs to be evaluated in the design of the hydrogen plant, because it's something more. I have my PLC, I have my DCS, I know how to manage the shutdown, I know how to work using the other transmitter to evaluate the condition of the if there is a catastrophic scenario in that way. We are talking about the small leakage, and the become negligence in this way, it means that the consequence of leakage is, of course, at the minimum level the out of service partially or fully of the plant. So is a loss of money, is a loss of production. And that is the minimum thing. However, our mission as an SA, we protect people at work and we want that they go back to their family at the end of the day. Okay, so a possible incident, especially with the hydrogen under pressure, the consequence is always affecting to people if they are present on the place where the situation is happening, and at least people can be injured, can lose their life, and that is the catastrophic things. What are the consequences of an explosion? What is a consequence of the negligence of not having the fire and gas detection system? Is also a reputation loss, because when today with the social media, it's quite easy to get the information about the catastrophic situation. Hydrogen
Mm.
is under the lens of many, let me say, stakeholders, detractor or sponsoring people or company. So what that means, immediately it will be on the mouth of everyone, the situation of a catastrophic situation. That is also think about how it will be complicated to restart the business after a partial or even a total shutdown due a consequence of a missing detection of the leak. I don't want to make any, psychological terrorism here. I don't want, but when I say we are pushing, we are touching the pocket of the people and the hurt of the people. That is the sense I meant. Um, we are we have not to play with the life of the people, and also I will say we have to be careful not to have damage or even compromise the business of the company, because we are all doing business. So our mission is to protect in this way, and I will invite here the audience or whoever can see that the video. Then safety is an important requirement of the hydrogen in the hydrogen supply chain. Is part of the concept to compensate the possible risk. Okay, it is a balance. Um, it will never happen nothing. These are the words I heard sometimes. Oh, my plant is safe, is well done. I'm using the right techniques. It's not a matter of when we are doing the commissioning of the plant, I can tell you everything, it works always well. Everything is perfect. What about then the deterioration of the components where the leak source? And we are talking about the membrane, O-rings, filters. So there are sensible elements or consumable parts that are the most typical leak source. And this will happen maybe in 5 years if you don't do maintenance on the specific components. At a certain time, you will have a problem. You might face, and I hope that will never happen. So that's why the safety system is quite sensible and crucial for mitigating. And let me say, I'm not seeing a problem immediately in a short term, but think about the future.
Mm. Yeah, definitely. Thanks for your touching words, and I think you touched the audience. But that's why we have another
I hope so.
question. Um, the question is: is there any general guidance for quantity of detectors and positioning on site? Um, like, for example, one detector per each 10 square meters, or how can we evaluate this?
Well, yeah, I know where come from this question, because we say in the red side, in the fire system or extinguisher system, there
I
is a
think you
rule.
hear it more often, yeah.
Yeah. There is a kind of a rule where there is routes where there is a 5 meter coverage. Now, for the
Mm.
gas detector, and I think I've also explained it a bit, especially for the conventional gas detector, the sensor are smelling the gases. So that means that the cloud has to hit the detector. is the sensor is not going in the direction to smell like a dog, where the cloud is moving on. And at least we can use a specific technology, as I say, the ultrasonic, because it's hearing the emission of the noise of the compressed gas. Um, at least I mentioned something also during my answer a few minutes ago, is a fundamental of the sensor position rather than the coverage. Coverage is only related to the ultrasonic, like our detector is a 28-meter radius per 360 degrees, so it's a wide range of covering, like our ear can even hear the sound generated far away. But the conventional gas detector is sensible in the positioning rather than to consider the coverage area. Those are two total different things, because there is no any regulation saying the gas detector has a coverage area of X meter sphere or something like that. I've heard that some companies are considering a kind of coverage of the conventional gas detector in a limited meters in an open environment in outdoor. It's quite complicated to even prove this statement, because it's influenced by the dilution of the gases, the weight of the molecular of the flammable gas. We say hydrogen is lighter, but we can have also other type of flammable gases. So no, it's quite complicated to make this statement. And as a manufacturer, we never say the gas detector, the conventional gas detector, have a specific coverage area around the sensing element or the sensor.
Yeah. So it's really hard to evaluate, a general setup for applications like every 5 meters or so.
Yeah, but let me say that now in 2023 there are also software which, like MSA is using, is called the gas and flame mapping. So it's a very sophisticated service that even we can provide to with a final statement of the after a very deep evaluation of the behavior of the cloud, where to position the conventional gas detector or any other of technologies suitable for hydrogen or even other flammable gases. So I would say that the is a good age where we can also trust on this software. We know that the computers, the microprocessor, are very quick and very with a high level of reliability on this. We are using for application, complex application, but also, let me say, a small application where it requires something specific, especially outdoor. Based on the also the experience in the past, people were using their background or experience to evaluate the sensor positioning. Those are two different things. It's better to trust on a numeric factor rather than, like we say, the tumble roll, to say, okay, I believe on that.
Thank you. So, as I mentioned, I'm not an expert. You, with your presentation and your answering our questions, you make the business sound easy to me, providing effective safety solutions and handling all the potential consequences which might come up, and how crucial it is. But as everyone, as every company has, there are challenges. Right now or even in the past, and I think we focus on right now. But what are your current challenges when you face companies, and how you convince the customer from your safety?
That is that is a very tricky question, because maybe I say something before is it's not a matter of convince. Let me say, I strongly believe that what MSA is doing is called like the safety awareness. So is where the customer has to understand that the fire and gas system is an important solution, which is part of the other systems into the hydrogen plant, where the importance of this one is securing the safety of the plant. There is a standard, maybe some people knows the 61511, where they are describing the different layer of the system, and the our technologies, our products are in the external layer, which are related to the safety. Okay, so you have the first five are related to the process, managing the process, like the PLC, the DCS, and managing the flow, the pressure, something like that. So they make sure that the process is working properly. But outside, there are the five layers where is important to consider in order to protect the internal one. And in most of the case, or let me say, also the ATEX directive is saying that the gas detection system must be an independent system and disconnected to the process system. So why that? Because we can expect a fail or a compromission of the process management system. So the system, the safety system, must be independent because they have to, how to say, secure that the strange situation happening is managed by another brain and not on the same brain, because that is a kind of surveillance. It's like the police. It has to be external. It cannot be the same person that is doing the regular stuff during the day life. So to convince the customer is very sometimes complicated, even because in the green hydrogen we have seen a lot of new startup coming up, and you are experiencing on that. That's why H2UB is here. And those startups are coming from a different business where hydrogen maybe was not used before. Or let me say in another way around, MSA is working on oil and gas, where hydrogen is used every day in the refinery. So we are familiar with how to manage hydrogen, not managing a sense of process, how to manage the safety on detecting hydrogen. So it's not new to us. And let's remember, hydrogen is in our life since more than 40 years in a very heavy industries. Okay, it's not out of the road in the hydrogen fueling station. However, let's remember that 95% of the hydrogen produced today is mostly used in petrochemical or fertilizer industry. So it's not new. For us, it's quite normal to manage this leak behavior. So I will invite to, like you say, it looks that I speak on hydrogen like a very easy way. I'm strong on my shoulder that have a lot of experience. MSA is having a lot of experience in regulation technologies to detect hydrogen leak.
So yeah, as established company you already mentioned, you already have long time experience in handling hydrogen in the gas leakage with that gas. But I think in the last years some things might have changed in innovative ways. So I think there are a lot of startups handling with safety techniques and innovation. And so, how was your approach about the from the last years, and how do you maybe collaborate and support startups to accelerate H2 adoption? Is there any way you came in contact with and have your experience made so far?
Yeah, well, MSA is open to cooperate or support with other companies, especially when we are talking about the safety topic. Okay, our contribution is always to share our experience. Today is exactly an example of what we are doing. We are sharing our knowledge about the technologies. We are sharing our experience. We are putting our face in front of everyone in regards of our solution to mitigate the risk of the leak. And supporting other startups is always, we are always open to share, collaborating, and of course targeting on the topic of the fire and gas system, the technologies. That is something where we can contribute to make safer the life outside. So it's more contributing and collaborating,
Great, thank you so much. Yeah,
but
and
not to
we
our
see your
competitors, Robin, of course.
but we see you're yeah, eager to work with startups, and that's why you're part of the H2UB Hydroverse. And yeah, I really like to thank you for
Thank you
that.
to you, Robin.
And yeah, I think we had a lot of insights, and let us come to an end of this session for today. So thank you, Claudio, so much for yeah, staying up with us, being here today, and share your insights on how important safety measurements are. And ladies and gentlemen, I would like to thank you for yeah, tuning in. I will do a short roundup. I think we took away some very crucial points to remember. And yeah, people often think that, like me, the hydrogen gas rises to the ceiling because it's lighter than air. However, when it's pressurized, hydrogen leaks can be unpredictable. And that was, for me, a main takeaway of today's session. We need different technologies. But not every application might be the right for your flame detection and where to use it. So stay in contact with Claudio to yeah, get good insights on what technology to use, and yeah, how vital safety in industries like ours is when you handle with hydrogen to prevent explosions, fires, damage, and yeah, to prevent injuries and loss of life. And yeah, that's one of the main parts, I think. And as Claudia mentioned last, it's crucial for companies which have a rich experience to be open-minded and work with startups and see how they tackle the their topics with in an innovative approach. And I think this kind of knowledge transfer and cooperation is what the Hydroverse stands for. And maybe the audience has become interested in learning more about us, the H2Hub. So yeah, please reach out to me and my colleagues, and yeah, let's see what we can achieve together. So once again, a big thanks to Claudio and MSA for supporting us all the way we are doing so far in the last 2 years. Yeah, thank you to the audience, and thanks to all our cooperation partners. Um, Please stay tuned what our H2Hub Insight sessions might bring up in the future. And yeah, you'll always find our new programming on LinkedIn and on our homepage at h2hub.com. And I would like to thank you all for tuning in for today, and see you next time at the H2Hub Insight. And until then, goodbye. Have a great day. Thank you.